Hi everybody. We're going to get into the last lesson of the school year, which deals with L'Hopital's rule, which allows us to evaluate limits that take on a certain form. Okay, so one of the phrases that you're going to hear pop up is over here in red on the right, which is called an indeterminate form. And examples of indeterminate forms are something of the form 0 over 0, plus or minus infinity over infinity. You can have infinity minus infinity, 0 raised to the 0 power, 1 raised to the infinity power, infinity raised to the 0 power, or 0 raised to the, 0 times infinity. So the two that we're going to spend like this lesson looking at are 0 over 0 and infinity over infinity. So we are not able to, when we have limits in this format, determine what the value of the limit is without either using L'Hopital's rule, which we're going to discuss today, or some of the techniques that we used for limits earlier on this year. Okay, so let's take a look at what L'Hopital's rule states. So L'Hopital's rule states to suppose f and g are differentiable. And then it says if the limit as x approaches a of f of x divided by g of x is either equal to 0 over 0 or plus or minus infinity over infinity, then the limit as x approaches a of f of x divided by g of x is going to be equal to, so when we use L'Hopital's rule, the way that we do it, the way that we indicate it is we put an LH next to the equal sign to indicate that we are utilizing L'Hopital's rule. And as long as our limit takes on the form of 0 over 0 or plus or minus infinity over infinity, then the original limit is going to be equal to the limit as x approaches a of f prime of x divided by g prime of x. Okay, now a lot of times when you take the derivative of the numerator and the derivative of the denominator, you're going to be able to evaluate that resulting limit. Okay, but there are going to be instances, and we'll see that with some of the examples that we're going to look at momentarily, where we may have to use L'Hopital's rule a second time or a third time or a fourth time, depending on what the ratio of your functions look like. Okay, so when we take the first derivative of the numerator and divide it by the first derivative of the denominator, if we get a limit that we can evaluate, great. If it takes on the form 0 over 0 or plus or minus infinity over infinity, then we can use L'Hopital's rule a second time. Okay, so that's going to be equal to the limit as x approaches a of f double prime of x divided by g double prime of x. And if we need to use L'Hopital's rule more than twice, so be it. You guys can just continue that process. Okay, so let's take a look at a couple of examples evaluating limits using L'Hopital's rule. So the first one we're going to look at is one that we went over in the previous lesson. It's the limit as theta approaches 0 of the sine of theta divided by theta. Now, I asked you in the previous lesson to memorize that the value of that limit is going to be equal to 1. Let's take a look at why that limit is in fact 1. Okay, so when we take the limit as theta goes to 0, if we directly substitute 0 in the place of theta, we get the numerator to be the sine of 0, which is 0, and the denominator to be 0 as well. Okay, so that is one of the indeterminate forms for which we can use L'Hopital's rule to evaluate the limit. Okay, so if we're going to use L'Hopital's rule, then that limit is going to be equal to the limit as theta approaches 0 of the derivative of the numerator. So the derivative of the sine of theta is going to be the cosine of theta. And then we're going to divide that by the derivative of the denominator. The derivative of theta in our denominator is going to be 1. And then now when we directly substitute 0 in the place of theta, we get the cosine of 0, which is 1, divided by 1, and the value of that limit is in fact 1. Okay, so that is how we can use L'Hopital's rule to evaluate that limit. Okay, now let's take L'Hopital's rule and apply it to some earlier instances of limits that we've looked at. Okay, so with number 2, we have the limit as x approaches 2 of x squared minus 4 over x minus 2. Okay, so I'm going to do this example first without using L'Hopital's rule. Okay, so we're going to take a look at like techniques that we use to evaluate limits of this type earlier in the school year. So first thing we always wanted to try was to use direct substitution. And if we use direct substitution, if I plug 2 in the place of x, the numerator would be 4 minus 4, which is 0. The denominator is 2 minus 2, which is 0. So if you guys remember back earlier in the school year, if when we tried using direct substitution and we got our limit to be of the form 0 over 0, we had a couple of techniques that we could use to evaluate this limit. So the 3 techniques that we could use to evaluate a limit of this type, number 1 was to factor the numerator and denominator. Number 2 was to multiply the numerator and denominator by a conjugate. And then number 3 was to simplify the numerator and denominator. Because if we got a limit of the form 0 over 0, that told us that our original fraction was not in lowest terms. So I think factoring is the best approach here because the numerator is the difference of 2 squares, so that's going to factor 2x minus 2 times x plus 2. The denominator is x minus 2, and then we can eliminate the factor of x minus 2. So when we did that, we could then use direct substitution. When I plugged 2 in the place of x, we got the value of that limit to be equal to 4. And if you guys remember, earlier in the school year, that told us that we had a hole at the point 2 comma 4. Okay, so that would be how we were initially taught how to evaluate a limit of that type. Okay, now if when we use direct substitution, we get something of the form 0 over 0, that also tells us that this limit here is a candidate for L'Hopital's rule. Okay, so if I want to use L'Hopital's rule to evaluate the limit, then that's going to become the limit as x approaches 2 of the derivative of the numerator, which is 2x, divided by the derivative of the denominator, which is 1. And then now if we use direct substitution, when I plug 2 in the place of x, 2 times 2 is going to make the value of that limit equal to 4. So you get the same limit either way. I actually think L'Hopital's rule in this particular case is probably even easier than factoring both the numerator and denominator. Okay, let's move on to number 3. So for number 3, we have the limit as x approaches 0 of the sine of 4x divided by x. Now, we took a look at how to evaluate that limit in the previous video without using L'Hopital's rule, but we also see if we try using direct substitution here, when I plug 0 in the place of x, the numerator becomes the sine of 0, which is 0. The denominator is 0. So that is an indeterminate form, 0 over 0, which means that is a candidate for L'Hopital's rule. So if we use L'Hopital's rule to evaluate this limit, this becomes the limit as x approaches 0 of the derivative of the numerator, which using chain rule is going to become the cosine of 4x times the derivative of the inner function, which is 4, divided by the derivative of the denominator, which is 1. And then when we use direct substitution here, we get 4 times the cosine of 0, which is going to be equal to 1. And 4 times 1 makes the value of that limit equal to 4. Okay, so I'm going to have you guys give 4, 5, and 6 a try. So I want you to pause the video to work on those. For number 4, we have the limit as x approaches 1 of the natural log of x divided by x minus 1. For 5, we have the limit as x approaches infinity of e raised to the x power divided by x squared. And for 6, we have the limit as x approaches infinity of the natural log of x divided by the square root of x. Okay, so go ahead and pause the video to give those three examples a try. When you're done, unpause and we'll take a look at these together. Okay, so let's take a look at number 4. Again, if we try using direct substitution here, we get the natural log of 1, which is 0, divided by 1 minus 1, which is 0 as well. So again, that's an indeterminate form, 0 over 0, which means that this limit here is a candidate for L'Hopital's rule. So if we utilize L'Hopital's rule, we take the derivative of the numerator, which is 1 over x, divided by the derivative of the denominator, which is 1. And when we evaluate that at 1, we get 1 divided by 1, which makes the value of that limit 1. Okay, with 5, we have the limit as x approaches infinity of e raised to the x power divided by x squared. So again, the way we want to think of this, as x gets large, e raised to the x power is going to go to infinity. So that numerator goes to infinity. And as x gets big, the denominator x squared also goes to infinity. So again, that is an indeterminate form. It is infinity over infinity. So let's use L'Hopital's rule to evaluate the limit. All right, so when we use L'Hopital's rule, this becomes the limit as x goes to infinity of the derivative of the numerator. So the derivative of e raised to the x power is e raised to the x power, divided by the derivative of the denominator, which the derivative of x squared is 2x. And again, as x gets big, the numerator goes to infinity. The denominator also goes to infinity. So that is still in an indeterminate form, which means we need to use L'Hopital's rule a second time here. Okay, so that's going to give me the limit as x goes to infinity of the derivative of the numerator, which is e raised to the x power, divided by the derivative of the denominator, which is 2. And as x gets big, e to the x power goes to infinity. Infinity divided by 2 is infinity. So the value of that limit is infinity, which means that the numerator is growing at a faster rate than the denominator is. And if you think about that, that should make sense. The exponential function e raised to the x power is going to grow significantly faster than the function x squared does. Okay, with 6, we have the limit as x approaches infinity of the natural log of x divided by the square root of x. Again, as x gets big, both the numerator, the natural log of x, goes to infinity, and the denominator, rad x, also goes to infinity, which means this is a candidate for L'Hopital's rule. So if we want to use L'Hopital's rule to evaluate the limit, we take the derivative of the numerator, which is 1 over x, divided by the derivative of the denominator. So that's going to be 1/2 x to the negative 1/2 power, or 1 over 2 rad x. Okay, so when I simplify that, that's going to become the limit as x goes to infinity of 2 rad x divided by x, which is going to become the limit as x goes to infinity. That expression is going to simplify to 2 over rad x. Okay, so as x gets big, we get the number 2 divided by some huge number, and that's going to make that limit go to 0. And hopefully you guys remember from earlier in the school year, if you take the limit as x goes to infinity and you get a finite number as an answer, that means that your graph has a horizontal asymptote at y is equal to that number, which in this case is 0. Okay, last example of the school year. So for 7, we have the limit as x approaches 0 from the right of x times the natural log of x. So just to review this really quick, when you have your natural log function, as you approach 0 from the right-hand side, those values there are going down to negative infinity. So here you have something of the form of 0 times negative infinity, okay, which is an indeterminate form, but it's not an indeterminate form for which we're going to utilize L'Hopital's rule yet. So what we want to do here is we have to take this function and manipulate it or rewrite it where it's of the form 0 over 0 or infinity over infinity. Okay, so what we can do in this particular case is I can rewrite this. So this is going to become the limit as x goes to 0 from the right. I'm going to rewrite this function here as the natural log of x divided by 1 over x, because this expression here and this expression here are equivalent. They're exactly the same. I just have it written in a slightly different format. Now, the reason that I want to use the expression in blue is when we take the limit as x approaches 0 from the right-hand side of that expression in blue, the natural log of x as x approaches 0 from the right goes to negative infinity. And if you think about the graph of 1 over x, which looks like this, as you approach 0 from the right-hand side, that graph goes to positive infinity. Okay, so that is in the indeterminate form that we want in order to use L'Hopital's rule. So there are times that you have to take the function that you are given and like algebraically manipulate it to put it into a form for which we can use L'Hopital's rule to evaluate the limit. Okay, so when we use L'Hopital's rule here to evaluate the limit, we're going to get the limit as x approaches 0 from the right of the derivative of the numerator. So the derivative of the natural log of x is 1 over x, divided by the derivative of the denominator. So the denominator, 1 over x, is the same thing as x to the negative 1 power, which using power rule, the derivative of that is negative 1 x to the negative 2 power, or negative 1 over x squared. Okay, so when we use algebra then to rewrite that, we get the limit as x approaches 0 from the right. That expression is going to become negative x squared over x, which becomes the limit as x goes to 0 from the right of, that's going to become negative x. And as x approaches 0 from the right-hand side, negative x becomes 0. Okay, so the value of that limit is equal to 0. Okay, so this technique, L'Hopital's rule, is a good technique for you to know just on its own, just for like evaluating certain types of limits. And it'll also be helpful for you in your 11.1 homework to go over maybe some of the limits that you were having difficulty with in that lesson that dealt with trig functions. Okay, so if you're having trouble with 11.1, maybe this lesson here will help you evaluate some of those limits involving trig functions, and it'll help you work through the L'Hopital's rule worksheet. Okay, guys, so that's it for this lesson, and that's it for what we're learning this year. We're officially done learning new stuff. Okay, so you guys will have a quiz to take on Chapter 11 plus L'Hopital's rule in class next week. Hope you guys have a great weekend. We'll see you all in class on Monday. Bye.